Domain of rational functions. The domain of a rational function is the set of all real numbers that make the denominator non-zero. In other words, the domain of a rational function is the set of real numbers except for the values of x, which when substituted to the function will give undefined results or indeterminate form 0 over 0. Notice that both cases have 0 in the denominator. This means that we must exclude the values of x that will make the denominator 0. To solve for the domain of a rational function, set the denominator not equal to 0, then solve for x. Case 1. Denominator is linear. Example 1. The denominator is x. So we just let the denominator not equal to 0. So the domain of the function is x is not equal to 0. If the domain should be expressed in set builder notation, we write it as x such that x is an element of real number where x is not equal to 0. If the domain should be expressed in interval notation, we write it as the set given by the interval form from negative infinity to 0 union with the interval from 0 to positive infinity. Take note of the use of the parentheses rather than brackets. Parentheses is used to indicate that the value at the end of the interval is not included in the domain. Example 2. The denominator is 11x. So 11x is not equal to 0. Divide both sides by 11, we have x is not equal to 0. By observing the answers to the two previous examples, we can say that if the denominator is just the product of a number and x, the domain is always the set of real numbers except 0. In general, if the denominator is in the form ax raised to n, the domain is always the set of real numbers except 0. Example 3. The denominator is x minus 2. X minus 2 is not equal to 0. Transpose negative 2, we have x is not equal to 2. Example 4. The denominator is 2x plus 5. 2x plus 5 is not equal to 0. Transpose positive 5, we have 2x is not equal to negative 5. Divide both sides by 2. X is not equal to negative 5 halves. Case 2. Denominator is quadratic, where the quadratic is factorable. Example 5. The denominator is x squared plus 7x. X squared plus 7x is not equal to 0. Its factored form is x times x plus 7. Let each factor not equal to 0, then solve for x. First we have x. So x is not equal to 0. Next, x plus 7. X plus 7 is not equal to 0. Transpose positive 7, we have x is not equal to negative 7. Example 6. The denominator is x squared minus 9. X squared minus 9 is not equal to 0. Its factored form is x plus 3 times x minus 3. Let each factor not equal to 0. First, x plus 3. X plus 3 is not equal to 0. Transpose positive 3, we have x is not equal to negative 3. Next, x minus 3. X minus 3 is not equal to 0. Transpose negative 3, we have x is not equal to 3. Example 7. The denominator is x squared minus 10x plus 25. X squared minus 10x plus 25 is not equal to 0. Its factored form is x minus 5 times x minus 5. Since the factors are identical, we will just use x minus 5 not equal to 0 to solve for the domain. Transpose negative 5, we have x is not equal to 5. Example 8. The denominator is x squared plus 2x minus 24. X squared plus 2x minus 24 is not equal to 0. Its factored form is x plus 6 times x minus 4. X plus 6 is not equal to 0. Transpose positive 6, we have x is not equal to negative 6. X minus 4 is not equal to 0. Transpose negative 4, we have x is not equal to 4. Example 9. The denominator is 2x squared minus 16x plus 30. 2x squared minus 16x plus 30 is not equal to 0. Let's factor out 2 first. We have 2 times the quantity x squared minus 8x plus 15 is not equal to 0. We can still break down x squared minus 8x plus 15 into x minus 3 times x minus 5. X minus 3 is not equal to 0. Transpose negative 3, x is not equal to 3. X minus 5 is not equal to 0. Transpose negative 5, x is not equal to 5. Example 10. The denominator is 6x squared minus 5x minus 4. 6x squared minus 5x minus 4 is not equal to 0. Its factored form is 3x minus 4 times 2x plus 1. 3x minus 4 is not equal to 0. Transpose negative 4, we have 3x is not equal to 4. Divide both sides by 3, x is not equal to 4/3. 2x plus 1 is not equal to 0. Transpose positive 1, we have 2x is not equal to negative 1. Divide both sides by 2, x is not equal to negative 1/2.